The objective is to create killer rhythms that make people want to dance. Now, that's a tall order, of course, because it's like asking how do you write a hit song. But I think something can be learned about groovy rhythms by experimenting with rhythms that can be adjusted minutely. So that gets us to the idea of like micro-timing of rhythms. But anyhow, before I talk a little about that, I want to just say I started listening to rhythms when I was about 13 years old, lying in my bed on 47th Street in Manhattan in our tiny little apartment, listening to gospel music on Sunday morning, and I found myself tapping my finger to the rhythm. And I didn't know how I was doing that, but I liked doing it, and I've been doing it ever since. Fast forward. I write this book about a year ago called Microlects of Mental Models. It has two ideas in it. One idea is the idea of microlects. Let's not talk about that, but a microlect is basically the language you use to talk about a mental model. Never mind that for now. The other key idea in the book is the idea of micro-timing machine, which is a mathematical structure that allows one to build theories involving timing and probability. So much for that. How do you implement experiments with micro-timing? Well, before I talk about that, I just want to say there's a book by this fellow named Tiger Roholt called, hold on a second, Groove, a Phenomenology of Rhythmic Nuance. He's a musician. He understands that grooving is a bodily activity, not a mental activity. For example, he writes about a PhD thesis that was written called Embodied Mind, Situated Cognition, and Expressive Microtiming in African American Music. Yes, that's what I'm interested in. Salsa, Afro-Cuban music. You know what I'm talking about. A little whiles back, I wrote this paper called Microtime, Signals Between Operations in the World, which is kind of a huge idea based on microtiming, and goes all the way into the brain and neural network, artificial neural networks using microtiming machines. And I'm not alone in thinking about such things. For example, there's this really productive scientist named Edward W. Large, who's written a series of papers. For example, this one, which is like the granddaddy of his work in studying how biological neural networks feel the pulse and the meter of a rhythm. And he builds artificial neural networks to experiment with that idea. And this was the paper where he laid out the basic mathematical model. It's called a canonical model for gradient frequency neural networks. Very complicated, extremely interesting stuff, going right to the heart of the mathematics of dynamical systems, resonance, and one of the major questions that he addressed and seems to have found an answer to is the question that, you know, there are rhythms, clave rhythms, for example, where the pulse is not in the sounds of the rhythm, and yet musicians and listeners and dancers feel that pulse. He came up with a possible neural network model that feels the missing pulse. And I think he should be really famous for that, and I think he thinks so too. I have a slightly different take on where the rhythm is felt. I think the rhythm is not felt in the brain. It's felt in the body. And that's very consistent with Roholt's book. When they talk about embodied cognition in that quote I gave, that's what they're talking about, is the groove is in the body. And so it gets into an interesting idea. How does the body get into a groove? How does a body resonate with the pulse in a rhythm? And my idea is this. The body is a mechanical system. That's not all it is. I'm not trying to say that's all it is, or say that the whole world is made out of physics and all of that. I'm not saying that. I'm just saying when we move around subject to gravity with the use of our muscles and swinging our little pendulums and doing our motions in dance, we are a mechanical system which has certain resonant frequencies. There are certain things we can't do. and many things that we can do. It's called dance. And then I came up with this question. I put this question up on ResearchGate. No answers, but it's a funny little question. The question says, if zebras danced to their own music, what rhythms would they prefer? The idea being that since a zebra's body is so different from a human body, the resonances of that mechanical system, the zebra's mechanical system, would give rise to a completely different family of preferred rhythms. But let's stay with the human rhythms and just say, how do we hope to experiment with human rhythms? Okay, the answer I propose is a machine. This is very preliminary stuff. What I would wish for, what I would hope for. What would I hope for? I would hope for funding. I would hope that somebody finds the possibility that we could discover a way to create killer rhythms might be worth investing in. And there's lots of ways to do that. Maybe I'll write a book about it. I started writing a book about it. Well, I don't know if it's a book, but I have this thing called Microtime Nuance and Body Resonance in Musical Rhythm. This is a work in progress. The code for the experiments that I'm about to demonstrate is in appendices of this thing, and I don't know how I'm going to publish that. Maybe I'll put it on ResearchGate. Could do that. But anyhow, let me play some stuff for you so you get an idea of what some of these experiments sound like. Cut! Okay, so Edward Large has what he calls the neural resonance hypothesis, and he implemented a machine in software with 289 artificial neurons arranged in a very special way. Why 289? I don't know. 289 is 17 squared, but his papers don't explain where he came up with that number. Anyhow, I propose an alternative to his neural resonance hypothesis, which I call the body resonance hypothesis. Neural means in the brain. As far as one could tell, you could have a brain in a vat with a neural resonance machine and still feel the pulse in music. And I'm saying, not so much. I think that you need a body to feel rhythm. So I'm thinking of the body as a mechanical system. I'm not trying to say that the human body is a mechanical system and that's all there is to it. Of course it's much more than that. Everybody knows that. But the point is, it is a mechanical system in a gravitational field with certain muscular tensions and relaxations, certain masses connected at certain angles with certain limitations of motion, all of which determines a system of constraints on how the body can move and dance. My hypothesis is that the musical rhythms we prefer are geared to the way our body moves. How do we experiment with that? Well, I think short of having a musical group at your beck and call to do anything you want with their instruments day and night, we'll make a machine that allows us to experiment with micro-timing nuances. So this is the machine. This machine here is made out of parts from SparkFun, S-P-A-R-K-F-U-N. It has 4 Arduino microprocessor boards. They're called the Uno board. That's one in Italian, Uno. Right? Okay. It's got 2 wave trigger boards, which, by the way, is some of the most beautiful engineering I've ever seen. This little board, it's not expensive. It allows you to trigger, I think it's 14 different sounds at the same time if you want to. It's polyphonic. And it's very simple. You attach it to a speaker, you trigger it, it makes a sound. And I'll demonstrate that in a moment. I've also got a sound detector board and 2 capacitive touch switches and a bunch of wires. And what you do with Arduinos is you write code. It's a version of C. It's a very simplified version of C. There's plenty of documentation, plenty of schematic diagrams. You can learn everything you want to know about these boards. By the way, they publish even the instructions for how to manufacture the boards themselves. It's all like open source. Arduino is a utopia for people who want to build things involving little inexpensive computers. Here's another interesting book, Understanding Clave, which is the Spanish word for key. It's the key to Afro-Cuban music. Clave changes, because there are musical compositions where they change the clave as it goes through the piece. Singing, clapping, and dancing exercises, a supplement to the Beyond Salsa series by Kevin Moore. This is a huge publication adventure. It's for musicians who want to learn salsa. Anyhow, I like this page because it has on it 19 clave patterns. They're represented by X's and O's. As far as I'm concerned, that's a binary number, ones and zeros. And they all have the same length. They're all of length 16. In other words, these are patterns that repeat every 16 pulses. Okay? You just go around and around and around. So in mathematics, we say when you go around and around and around, we call it modulo 16. In other words, you go from 0 to 1 to 2 to 3 all the way up to 15. When you get to 16, you call that 0 again. By the way, this is not a new idea. A clock starts at 12 o'clock, goes 1, 2, 3, 4, comes around to 11. When you get to 11, you start over again. Okay? So a clock is modulo 12. These clave patterns are modulo 16. Now there's 19 of them. So I wanted to demonstrate each one of them. So the touch switch, I will show you in a moment, the touch switch allows me to go from one to the next and then start over again. So I'm going modulo 16 in the rhythm and modulo 19 in the demonstration. So I've got two modulos. Sort of think about a donut. You know, you can go around a donut in two ways. You can go around and around through the hole, or you can go around and around on the outside. That's a mathematical structure called a torus. Anyhow, you want to hear it? Check this out. That's a 3-2 clave. Okay, now I'm going to go to the touch switch and move to the next rhythm. I think that's a rumba. Boom, 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 boom. Here's another one. I like that. Okay, that's the beginning of the cycle, and I just wanted you to hear a whole bunch of those because they're really interesting. They all make you want to dance. This is only a machine. It's not a musician, of course, so you wouldn't want to spend a whole lot of time with that. But that's just the beginning. There are a lot of experiments to be done. Let me just show you something about how that was achieved. I took all of these clave rhythms on page 73 here. I took those and I put them right into the Arduino code with labels. And so you can see that I translate these, I think they call this like box notation in the book, translated into binary numbers. Very, very mathematical. sounds are being produced by these wave trigger cards, which have the sounds recorded on these SD microcards. All of those sounds were made with instruments that I recorded and then modified a little bit for aesthetic purposes using Audacity software.